This conference will now be recorded.
Before we jump into the technical discussing today, a few announcements. The first one is the SONiC workshop before summit. Let me show my screen. Can you guys see my screen?
Yes.
Yes, Xing.
Oh, thank you for confirming. So this is OCP calendar. As you can see that summit is March 14 and 15th. We have a SONiC site workshop. If you click here, it will have the details of the workshop. The place is at Lincoln campus. It will be 2 days. You can participate in 1 day or both. The first day will mainly be technical talks until afternoon. And the last 1 hour of the first day will be preparation for the second day of hackathon. The second day, we are going to do a 1-day hackathon. Use virtual switch SONiC image on your laptop. So the tech talk, we are working on the schedule and the planning. We will continue beefing up this plan. So this is the registration link. I'm going to put on the chat window. Okay. So this is the first announcement. The second announcement, I have sent email to the community mailing list that call for participation of demo. If you have participated in the previous OCP, you know that we have full rack of SONiC demo of SONiC capable switches. You can participate either in a static setup or in a setup that can demonstrate warm reboot functionality. So watch out to the community mailing list. It has detailed time, when to ship, and address to ship your address. Yeah, and please feel free to reach out to me on any questions. With that, we are going to start today's discussing. It is driven by Don from Alibaba. This is about investigating the performance of this Redis DB, how to make it better. Hi, Don. Can you hear me?
Yeah, I can hear you.
Okay, I'm going to make you the organizer and the presenter.
Okay.
Okay. And I'm going to stop sharing. 1 second. Okay, I'm going to make you the presenter. And you can share your screen now.
I need to install a plugin. Give me 2 minutes.
No worries. Okay, we can see your screen.
Okay, now? Okay.
Yes.
See me now? Okay.
It's go to meeting.
Yeah.
Okay, now we can see the wiki.
Okay, that's good.
Okay, I'm going to mute myself and anyone. If you are not speaking up, please mute. Yeah, for the best audio experience. Yeah, let's go ahead, Don.
Okay. Hi guys. Today I want to introduce something about the Redis running on the SONiC software. And basically, today, when we using the when we use the SONiC image, there's only one database instance, and everything is write into the database and read from that only database instance. And we did some experiment offline, and we found that if we can have a multiple database instances, for example, we can divide the data into two database instances, and then we found the performance could improve about 20 to 30%. That means, for example, I have a lot of data I want to write into a database. If there's only one database instance, for saying it costs about 10 seconds. And then if we have two database instances and we divided those entries, we write into the one database instance into two, then we can save about 2 or 3 seconds, and we only need about 7 or 8 seconds to write the same amount of data. And then that's why we propose this design. We want to change the current design. We want to have multiple database instances instead of only one. And then we did some research on the current database, the current usage of the Redis database instance. Then for today, the Redis database, it's start from here. It's a brief picture. It shows how the when we reboot or start the SONiC image, what happened. First is if we have some old configuration in the last version or in the last image, then the SONiC will copy this configuration here to this directory, the host, the old config. And then when we start the system, the RC local copy those host old config directory to etc SONiC. This is the directory we are very familiar with. And then the database Docker will start, and database Docker start, and they start only one Redis database instance here. And then after the database start, that means that the instance is up, and then everything else happen. And then we can restore the config db.json file and some other stuff. And then the system is running, and all the features are running based on this database instance. And then this is what happened today. And what we want to do is when we start a database Docker here, we want to create multiple database instances instead of one. And then the design we have is first we need to have a configuration file. Then we know how many database instances we want to have and how to allocate those existing databases. For example, now we have the appdb, asicdb, configdb, and blah blah. There are a lot of DBs, and some user can define their new database. But we need to have a config file to store this information. Then we know, for example, this is a sample. For example, in this sample, we have 1, 2, 3, 4, 5 database instances. And then on instance 1, we say that Redis port is 6380. And on this instance, we have the log level DB, sysmonitor DB, counters DB, and also the user can change the order or change or whatever we want. And then after we have this configuration file, then later when the system is up, when the database Docker is up, then we can read this configuration file and make configuration correct. And here is our design. Our design is actually a little bit different from the current design. At the beginning, everything is the same, and the system could copy the old configuration file from the old image, and the difference start from here. And earlier we saw it, the database Docker and the RC local service. These two services they can happen at the same time. But now, because we want to use the configuration, then the database Docker should depend on this service. Then only when the old configuration copied into this location, then we can start the database service here. And in the database service, because at this moment we don't know how many database we want to start, and then the database stalker need to, before we start the database instance, we need to know how to start it, how many database instances we want to we want to have, and then at this point in the database, in the current database supervisor D, we add a new program. Is called, actually this is a script, and in this script we call some other script to create all the Redis config. Actually, in this script, what we did is we just read this file, this configuration file, and we keep the mapping from the database to the instance name and the port. Also, we can generate the database socket name from this configuration file, and then we save this mapping. Next time, when we try to use the database from this mapping, we can look up where to write this key value pairs. And let's go back to here. And then actually, when the database starts in the supervisor D, we add a new program start.sh. And then after we create all the Redis configurations, and then we generate a new supervisor D config file. This is different from the original supervisor D config file, because the original one is decided when we compiling the image, but this config file is decided during the runtime. And then when we have this new supervisor D config file, in this file, actually we based on this configuration, we can decide how many database how many Redis server per size we want to have, and then we update those config this supervisor D. We use the reread and update, and then we start those new added Redis server. And then at this moment, we have all the database, we have all the Redis instances we want to have, and and it's the same as what we described in this configuration file. And then after that, everything is the same, and all the features can start running on all these Redis instances. And then this is the first step. After we have those Redis database instances, the app should have the ability to use these multiple database instances. Then that means we need to change the code in SONiC image, because today in the code thought all the features think there is only one database instance, and by default all the features write the data into that only database instances. And then here we just described what I'm saying just 1-2 minutes ago, and let's continue to I'll introduce this last. Let's go to the interface design. So actually, in the SONiC image, in the SONiC codes, we have C++ code, we have Python code, and also we have the Go. We sometimes use the Go programming language, and also we have some script. And in all these situations, we are using the database, the Redis instances. For example, for the C++ codes, usually we are using this DB connector. Today, we have these two methods. When we try to connect the database, we give the database name, the database ID, and the host name, the Unix socket. And from here, we know which database we can connect. But usually, in our code, we are using something like this. Like this. This is hard coded. This is today how we use the DB connector. And then this is fixed, and we cannot change it. And in the new design, I just introduce a new method, and we don't need to input the socket name or the port plus the host name. We just give the ASIC DB name, and from this ASIC DB, we just give the DB ID here. And for example, this is the ASIC DB, and then from this ASIC DB, we can look up the mapping. Remember, we have this this configuration file. We can look up this mapping, and we know here, for example, here say ASIC DB is on instance 4, and the port is 6383, and then we know which database instance we can connect for ASIC DB. And the design, the detail of the design is we introduce a new class here. We introduce a new class here. This class, what this class doing is just pass that configuration file and save the mapping information. Here you can see we store the mapping information here from the DB name. We can know which DB is for example the app DB is 0 and the ASIC DB is 1, and then we store that information here. And here is we store the information from database 0. Then we know what's the port and what's the socket path. And from this mapping, we know this information. And also we provide to a get function. And then from the database ID, then we can get the socket name and the port. And in the existing DB connector, we add this new method. And in the code, in the C++ code, we need to replace all this method with this new one. And then the app will don't care what database they want to connect. They only need to provide the database ID. And then in the database ID, when we try to connect the database, instead of hard-coded the socket name or port, we just call this function, call this get function. This get function actually, we declared a static member of this class in the DB connector, and then this one is initialized only once when we have the DB connector object, and then we call this get function to get the socket name or to get the port, and then we can connect to the correct database instance using this way. This is for C++ design. So any question here?
Yeah.
Yes.
Can I have a question? So for right now, we use the two database Redis instances, right? Two, right? Hello.
Hello.
Yeah, I mean that we use the two Redis instances now, right? So how about the Docker containers? Yeah, just is that one to handle each of them?
No, we can have as many as instances we want. It depends on this configuration file.
How about the container? Is that some for DB handling? You know, the containers. How many containers? Do we need more containers?
No, this everything is happened. So today the database thing is happened in database Docker, right? And now everything is still happened on database Docker. The only difference is in database Docker we start more database instances instead of one.
Okay. Okay.
But
thank you.
All this stuff is happened still in database Docker.
Oh, I see. Thank you.
Yeah, actually, don't I actually have a question or just have some maybe some issue related to it. So currently with the 1 DB instance, we could have 16 DB or 15 DB in maximum, right?
Yeah.
Now we could increase the number of DB instances from 1 to many more. Is it possible to support more than 16 DB?
Yeah, ideally, yes.
If you want to, if you want to support more than 16 DB, then is there any big change needed?
Probably one thing I can think is because this DB number is unique, right? For example, if we are trying to use this method, we just give this as a parameter, right? This parameter today we come from 0 to 16, right? 0 to 15. right?
Yeah, right.
But if we can make it unique, for example, we say we pass this as a string or something, and then from that string we can mapping that string to a database, mapping this string to an instance plus the database ID. Then that we can have more than 16.
Yeah, here this DBID it's integer type.
Yeah.
With the 16 database number of database, you just need 4 bits. There are still 28 bits you could use. Maybe that's a different answer, but I'm just this idea just popped up. I'm thinking if we need to support more than 16 DB in the future and how to do it.
Yeah, it's possible. The only thing is that we need to index all the DB. If we can make sure all the database name or there's some identifier is unique, then and from that unique value we can map into the correct instance plus the database ID. Then that's it.
Mm-hmm.
We need we need one more step mapping. Now we
Right.
only mapping the database ID name, and that means if we write the database 0 on instance 1, and then the database 0 on instance 2 and 3 is not used, then we need to plus some other prefix or something to make it unique. Then we can use the other database 0 on other database instances.
Okay, I got it. Okay, I mean, maybe we don't need this feature in the near future, but in the long term, there might be some need to support more than 16 databases. Okay, and I think that's when you write code, probably we need to take that into consideration. Let's say.
Mm-hmm.
Thank you.
And then the next is for the Python part. For the Python interface, one type of Python code is generated through the C++ codes. For this part, we don't need to change because the C++ code already changed. And then this Python code is automatically changed. And then another Python is the Python interface we are using is the SONiC v2 connector. Today we use it like this. Then we say we want to have a DB connect the DB connector. Actually, it's called SONiC v2 connector, and then we want to connect to database to some database, and then actually in the interface function, they just the Python just try to connect the database on the host, and what we change is similarly to what we changed in C++ code. In the Python, all this part of code, the database related code is in this SWSS SDK package. And then in the init function, we did a similar thing. We have some parsing function to pass that configuration file and keep the mapping from the DB name to the port and the socket name. And then also we provide two get function. From the database name, we can get the socket and the port. And then we keep this information. And later, when some other Python code try to use the database, they can look up the database name, and then they can find what's the port and what's the socket name. And then, for example, here. And after the changes, then we just need the usage is the same. Actually, we don't need to say we want to connect to which setup. Actually, it's itself. And actually here there's no changes. And then the only changes is here. This is the interface function in the Python when we try to connect the database, and then we finally call this function, and then I added this. In the new design. So today we don't have this. Sorry, I added this for the new design. Today we don't have this. Today we only try to connect the default value. The default value is this one plus the port 6379. And then in the new design, I just get the port number from the database name instead of the fixed 6379. This is the change for the Python. And then for the app, we don't need to change anything. because in the interface function we can convert the database name to the correct port, or we can change something like this. We can use the socket name directly instead of the port mode. So any question for the Python part?
Hello.
Hello?
What it means? You said we don't need to change the application for this thing, only on.
So because in the application, when we declare this one, when we have a SONiC v2 connector, actually at this time, we didn't connect to the database. Only when we called connect function, at this moment, we try to connect to the database. And when we connect to the database, finally we call this function in Python. And in this function, we just use the default. Today, we are using the default value. It's this host plus the 6379 that port. And at this moment, we change that fixed port to the dynamic one. We use the get function to get the correct port, and then that's it. Then that means we don't need to change this part, because when we connect, the interface will help you to get the correct port.
Okay, for the code base, is that involve a lot of change or only some places?
For Python, only this part and this init, we need to provide some passing function. That's it for Python.
Okay. So how about if? Okay, please go ahead. Sorry.
Okay, I mean for C++, it's similar. For C++, it's similar for the init part. Then for the passing part, we just provide some function to passing that configuration. But we need to replace all these places with the new one, because in this method we say which socket we want to connect. This is the fix. Is a fix the Redis dot socket name. Then we don't want to provide this. And that for the C++, there's more place for the application. For all the application which are using something like this, we need to change it to this.
Okay. So how do you think in the future, do we need more DB instances? You mean do you think that we can figure out an easy way for the expansion? So how do you think?
We just change this configuration file. So now we have 5, right? If we want to have 6, we can add one more. Similar to this. We can add one more here.
How about the coding part? The code.
The code we don't need to change.
Don't you? Okay.
Only this configuration file. Then the database Docker will read this file and see how many instances we want to have, and then at that point they will start. Here is 5, then we'll start 5 instance. If we have 6, then we start 6.
Okay. Thank you.
I have a question here regarding the Python interface. I think besides the SONiC virtual connector, we have another one. It's a config DB connector. I'm not sure whether you have checked this. Will it also need similar
Config.db
change?
actually is using this one. It's a wrapper of this one.
Okay.
Like the config.db, also we have some other DB, I think. Yes, there's some wrapper of this class, but that's fine. If this is changed, then for those things like config.db, that doesn't matter.
Okay, thanks.
And then let's go to next. Next one is the Go. For the Go part is for the telemetry feature, we are using the Go programming language. And this part actually is similar to the C++ code. And today, what we have is something like this. When we try to create the connection to the database instance, we use the fixed value. Here we say we want to connect to today's Redis socket file, and then this is the DB name. DB name is here, and then similarly to the C++ code, in the very beginning we need to pass that configuration file, and we got a mapping from the database to the socket name, to the port number, And then what we do is very almost the same to the C++ code. And this is in Go programming language. We pass the file and save the mapping. The mapping is from the DB name to the the DB name to the socket, DB name to the port, and then when we try to use it for here, we just use this get function to get the correct database instance. And here we are using the socket name. And then after this init part, all the database is connected to the correct database instance, and then the app in can use it. And then this is the change we need for Go programming language. So any question for this part? Okay, let's go ahead. And besides these three main languages, C++, Python, and Go, and we also have some static script which is using the Redis CLI. For example, I can provide some example. For some shell, we are using this Redis CLI, and for some Python code, we are using this Redis CLI. And also for some C++ code, so I did a global search, and I found for the C++ code, sometimes we are using the Redis CLI, and then we call the system call to connect to the database. And then for this, in this way, then we don't have a good method. It's not like the C++, Python, we have the interface to change. For this part, what we can do is, so I propose is because this was when somebody writes something like this, we already know which database we want to connect. For example, here the 4 is config DB, and then we can insert this part. This part is because for the Python code, we already have that mapping. Then we can import that mapping. We can import the SWSS SDK package. We can import this to we can import this get function to get the use this get function to get the correct port, and then we can connect to the port. Similarly, we can use the socket name here as well. And then after we insert this part, then we can connect to the correct database. And similarly to the Python code, so besides we say which database we want to connect, we need to insert a string like this, and then we need to tell which database instance we want to connect. And similarly for C++, we insert this part to choose the correct database instance. Yeah, here is we need to change all the places we are using a database like this. Any question here? Okay, actually, this is the main design of how to provide the multiple database instance in SONiC. And then also someone asked some question before, say we are using multiple database instance in this way. It's possible, but can we use it? Can we use the Redis cluster for the multiple of the Redis cluster to provide the multiple database instances? And we did some research, and it is possible to do that, but it's more complicated. And I don't want to introduce details about this part. If someone interested, you can read this part. And the main thing is for the I just give some brief introduction here. For the Redis cluster, we create multiple database instances, and all the instances connect to each other. And then when the client try to write into the database, it's not like it's not like today we say which database table, which database we want to write. For this case, we just provide the key value pairs, and then the system, the Redis system, will do a hash on the key and then choose which database instance to write. And then they use some hash function like this. And then the read is similar. When we try to read some key, then they use a hash function to get the correct database instance and then to get that value. And then if we configure something, we can see the Redis cluster like this. They divided all the instance, all the keys into some value here. This is hash key. If this one, then we send the data to this instance. If it falls in between this value, then it's to the other instance, and similarly the third instance. And the main point we find is in this mode, we must use the TCP plus the port mode. We cannot use the socket for the Redis cluster. This is thing. We don't want to use it for multiple database instances. Another thing is when we try to write into the database, we cannot say now today we say we want to write we say this 100 data into the ASIC DB because ASIC DB is 0. But in this case, if the key are different, those key value pairs may be mapped into different database instances. Then it's hard to control what we want to write. And also in this cluster mode, we need to replace the library. So today we are using the Redis library. So if we want to use this way, we need to change to Redis cluster library. Then this may be a lot of work. And then for the warm reboot, then because from the database to a database cluster, there's a big gap, then it's hard to handle it. And that's why we don't want to use this Redis cluster for the multiple database instance purpose. And let's see what else. Okay, next one, the warm reboot. Let's go to the warm reboot part. So for today, we have only one database instance. Then I checked the code for the warm reboot today. They did a Redis CLI save and save all the data into the RDB file. And then when the system is up, when the database is up, we restore the data from the RDB file. And then we restore all the data. Then that's it for today. But for our case, for example, today we only have one database instance. And then in the new image, we may have, we have 4 database instances. And then what I'm thinking is we can still do the Redis CLI save, and then we save this all the data into RDB file. But when we restore, we can restore all this data into one database. And then here is the here these two databases, they have the same information. And then after that, we can check that configuration file. We can compare the configuration file between the old one and the new one, and then we know and how to move those database. For example, here we can move the database 1 into instance 1, to move the database 2 into database instance 2, and database 3 into instance 3. And then we can use the Redis CLI. The Redis CLI provide a migrator method to do this kind of stuff. And then we can actually write a script to comparing the old configuration and the new configuration. And then we can find the delta. And then we can handle the delta part to move the database to the correct database instances.
So are you actually saying that the idea would be for warm reboot to take place after the Redis CLI migration is executed or before? The warm reboot reconciliation, basically.
This part is on the old image. On the old image, this part is already done, right? And when the new image is up, and then first we restore the RDB file into one. We can only install it into one database. And then we use the Redis CLI migrate those things.
I understand. What I was actually asking is the Redis CLI migration is meant to take before or after the warm reboot reconciliation is completed.
So it always
today
happens,
I don't think.
yeah, it always happens before the application level data restoration, right? Application expects data in the database before doing any warm reboot processing.
Docker, the post in the database Docker in the post action, we need to do this. At least before that post function, we need to do this. We need to make sure the database is up correctly. Then we can go to the next. So here, if we check this, so for this part, we are starting the database Docker, right? So at this moment, we need to make sure that that Redis CLI migrated is already done, and then we can finish the database service, and then all the other service can start.
So 2 questions follow up for that. Do you have a rough estimate for specific numbers, or at least the current scaling that we have in SONiC? How long does the migration take from one database to however many instances are configured? And the second CLI is that today I think with the database starts, but we don't. Do we actually? I can't remember. Do we actually wait before the rest of the Dockers start and the daemons come up?
The question 1, so I didn't measure the time, but I tried this command. This command works, but for me, probably data is very less. Probably have 2,000, 3,000. Then it's very quick, but I don't know the exactly time. And for your second question, the second question, so in the database Docker, when we start the database, we have a check script to check if the database instance is up or not. If it's up, then we thought the database Docker is started. Otherwise, we need to wait. We need to wait all the database instance is up, and then we can finish the database service, and then the other service can start.
No, that's fine. But what I was getting at is that if the rest of the Dockers actually start, because I don't think today we impose any restrictions in the ordering, so we just start the Dockers, right? So potentially the routing application Docker will start. The database may not be there.
No, the application Docker, they have some dependency on the database Docker. If database Docker is not start, the other Docker cannot start.
Okay.
Actually, that's not entirely true. So the dependency is at a service level. So the database service will start.
Yes.
And once the system control returns successfully, that doesn't mean that the database container is running. It only means that the service is started.
Yes.
But
so
today,
the other Docker services will start as well. If they don't, they're not going to wait.
Correct. But today, what we're waiting for is the database listening port become ready. So that more or less solves the problem today. But when we have multiple database instances and we need to do a migration, that opens up a window.
Yeah, it gets really complex, especially with things like the routing application, which, yeah, I guess it was writing in the app DB.
Yeah, because
So
you can probably imagine that you need to have DB1, 2, 3 listening port ready before you can do migration. But once the listening port is ready, other services can start to query those DBs while the migration is not done yet.
So the other problem is that I'm thinking of, and you guys can keep me honest if I forget something. So recently we did some work to try and decouple the routing application configuration to reside outside of the database. So if somebody actually does this, and we don't have a dependence for the routing application on Redis, so we're not going to read it from there. So the routing application as the Docker as a service will start. Routing application will come up, will read its configuration. Zebra won't be able to run. Well, actually, FPM won't be able to run to write to the DB. Things will start queuing up, and also things like GR timers or EORs will just expire before we actually had a chance to reconcile during warm reboot. So I think that's it seems to me that we may break that.
I mean, maybe there's some timing issue during we are doing the
No, it's not the timing issue. It's just that we I introduced some enhancements because we wanted to take advantage of the routing application configuration without having to wait for support for every little knob here and there that routing application can support inside the config DB, right? Which means that the routing application now doesn't wait for config DB to read its configuration or for the database to be up, right? So it will start, the Docker will start. The routing application is completely unaware. It will read its configuration and it will start opening sockets to the peers, right?
Mm-hmm.
And it will try to download the routes. And it will send the signal as well. And trust me, if you think Redis is quick, I can assure you BGP can be even quicker. So it will actually download all the routes, but if Redis isn't there to actually receive them and for us to run the reconciliation process, because we have to do all this Redis CLI migrate, it could very well be that we actually kill the routes. So we have to make some changes there to make sure that FPM, if the DB is not ready, doesn't actually, I don't know, doesn't actually, how is it going to deal with the reconciliation when the DB actually comes up? Because when the DB actually comes up, right, it has to read from the DB the current content of the routes and then try to reconcile based on what it received from FPM.
I think we do ping DB before it starts dependent services.
Say again?
I think we do have a ping of the DB before we start this dependent services today.
Well,
So
some of
might...
I think they have, but I think there's a question is when the DB is up, but the data is still in the, I'm saying, for example, at the moment, the database is still, oh, that should be fine because we can say the warm reboot is not done yet.
No, I think, are you able to stop the listening port from coming up before you finish the migration? If you can do that, then it's probably will solve the problem.
So I have one question about warm reboot. That part I'm not very clear. I'm saying is if something is not done, then we are saying the warm reboot is not done yet. At this moment, can we start some other services?
What do you mean by something is not done?
So for systemd, they have some order control. I mean, at what point do they think that that service has been up? Let's take a database for example. I think we have database startup script. I think once all the script has been finished, then systemd think it's done and could continue the next service. If
the script is service script though, it's not. It has nothing to do. It doesn't guarantee that the start.sh has been executed and finished.
No, like the guarantee that the database and the data has been restored. That has been guaranteed. If we check the that script, the startup script.
It's post start.
Yeah, but even post is part of the script. It is the whole. This is the Docker script. So I think the systemd will check the whole script instead of check the internal processing. Right?
We can run some tests, but I believe the post start script is after the service is done.
No, it's not post. It is Docker start script. It is a host script. I mean, what you said post or pre-start, that is a part of the script. I think the system is just check the host script instead of a specific command.
You could be right.
Yeah, we could do some tests or we could do some research offline. I think systemd is not that stupid. It's smart enough to check the finish of the specific script.
Everyone is pinning the database today, so that's naturally get time in line with the readiness of the listening port. Yeah, we need to run some tests to understand the timing better.
I think the same goes for FPM. I mean, we may have to consider if the DB is not there, maybe not accept the FPM connection. I mean, the routes aren't going to go anywhere, right? The DB is not there.
I believe we just need to verify the systemd has done its job. If it had done its job, then the problem is not there. It's not an issue.
But it's Japan. It's orthogonal, right? It's the two reconciliation things happening. One is at the level of routing application in appdb, and the second one is the one in SWSS, right?
Yeah, I think we're talking about database. The database restore or database the config.db load into the, the JSON config JSON loaded into config.db. That's all part of the service starter processing. That is controlled by systemd. If you're talking about upper layer application, I think that's different.
Right. But I mean, I'm interested in both, but I'm also interested, especially in the application layer, because it's not going to wait. And it also doesn't have a dependency anymore on any configuration from config.db.
Maybe I missed a point because we are talking about the database here. So
yeah. So after in warm reboot, right? We will try to reconcile the entries that we have in the appdb. And
yeah, appdb have been restored during the database startup processing.
That's the thing. So we have to make sure that even though, so today, as soon as we, okay. I mean, we can take it offline and look at this, but I'm not sure that things will work as is for FPM.
I think we do a similar thing, right? Today is we after warm reboot, we restore the data from other RDB file to the database instance. This is also in the database service, right?
Yeah. So if we check that systemd database.service file, they just call this database.sh start command. I believe only after this start command returned, then it start the next service. I mean, it was a service which has dependency on database. Once that start script is finished, then all the data has been restored to the DB. If we check the script.
Who can take the action item of figuring out those timings?
No, I think I just shared my understanding. I don't think it's an issue.
It would be nice to have a clear understanding. I mean, if we can get the current warm reboot working, then we can probably get the warm reboot working in the future. I don't think that's
Right. So
that's
moving
doable.
moving to multiple DB instances, that does not change all the processing order. It just means that in one step we're just doing a little bit more, let's say.
Okay. The different question is, what if somehow the service fails in between? Like there are some questionable steps that we, like for instance, we're rewriting the supervisor deconfiguration files and migrating the data from one DB to other. What if things goes wrong in between, and what if the service fails in between? Who is guaranteed that the next time when we restart DB, those supervisor control config files will be rewritten? Or can we pick up from where it failed?
So you mean where it failed?
Yeah, so what if something fails in between? Like you're in the middle of writing multiple config supervisor control config files. What if it fails right there?
You mean write that config file failed, or we read that configuration file failed? So I didn't.
Take it out of that context. Something like DB container gets stopped. It could be some other failures, not the failure caused by the procedure you're running.
We have some failure. If we have some failure for today, then what happened? It's still this part didn't change anything else.
Yeah, if we have failure today, then next time when we restart, we continue with the code reboot.
Yeah, if we do a code reboot, then everything starts from the beginning. Then it's fine.
But you introduced a new procedure of spawning from one single supervisor control file into multiple. What if something fails in between before you finish the expanding?
Then we start over from the beginning, right? Then when we do a code reboot, then we start that script again, and then for that script, then we'll overwrite whatever we have. Probably the wrong file or something. Then we can overwrite it.
Does it get overwrite after every code reboot?
Yeah.
Oh, if that's the case, then it's fine.
Because the location on something, everything is the same, then we will overwrite it. If we have some failure file, something there, then next time we will overwrite it.
So do we have like a base DB that we will always connect to port 6379?
Yeah, if the user, so then after some discussion, for example here, if the user configure something, then they must configure here. I didn't put it there. Then if the user want to use this configuration file, then they must configure. Actually, they can configure anything here. They don't need to. It's not necessary to have the 79. But if the user didn't configure those stuff, there's no. We only have this configuration file, but we don't have the context here. Then the system will start the 6379 base.
So do we actually want to allow this to not have a base instance running at 6379? Then does that actually work for Redis clusters or anything else? There's no dependence on the well-known assigned port 6379 at any point in time?
It's not necessary. If we change it to multiple database instance, we can use any port. It's not necessary to use 6379.
Hey, Dong, I think that this is a default configuration, right? I think probably you should put 6379 here.
Yeah, I can put it here, but I didn't put it here. This is for my testing. As I'm testing a lot of cases, and for this version, I didn't put it there.
So, Emily, I think this is a configuration, right? This is a user configuration. There's a default configuration and user could change it. User could change it to any value. And
by default, we can put the 6379 there.
Do we have anything depending on the default port number today?
Today, everything is hard-coded into the default port number. And that's why we want to change it. Need to change all the application which is using the hard-coded port number to the dynamic way.
So I can understand why you want to not use the 6379, so everyone uses the default one will fail and you will catch everything, right?
Yeah, then we need to change in the code. This is the design. The first design that we provide all these interfaces, and the second step is that we need to change all the code, which is using the hard-coded port or the socket.
Yeah. Does that in a way answer your question, Nikos, that we can actually run without that default number being enabled?
Yeah, that's fine. I'm just wondering whether there's going to be like, I mean, is it a good idea? And do we want to allow in the system if somebody runs a Redis instance at 6379 since we're not occupying it? Assuming that from what I hear, there is no dependence and we don't lose any functionality if we do that. But the question is, do we want to allow that in SONiC to have the ability for the user or the operator to run their own Redis at 6379? Is we're not going to be using it.
I think we should prevent that. I think we should put the 6379 here.
I would actually vote for the config DB or something like that to be anchored to 6379. I'm fine either way. All I'm saying is for the community to think about whether that is something that we want to enforce or whether it's okay. I'm fine either way. I don't mind. I'm just pointing it out.
I guess we just need to put it into this default configuration file, but the user has the freedom to modify and to change it.
Okay.
That might encourage silent failure.
Silent failure, meaning?
Yeah, like if some code is written really error protected that they retry forever listening to the original port. If the port is not there, they might have a chance to say that, hey, the port is not there. But the port there and DB is not there, they might be waiting forever. I don't know. Just a thought.
Yes, and I'm not sure what that would do to a system though. Depends how actually people write their code. Anyway, doesn't matter.
Mm-hmm.
Yeah. Then after that, we need to ask people to using the new method to connect to database DB. Don't use the old way. In the old way, probably if the default 6379 is not up, then if we use the old way to connect to the database, then it will fail, right?
Yeah. So we're saying that basically we will allow the option to not have for the user to not configure 6379, but by default we will use 6379 in the config for one of the DB instances, correct?
No, I'm saying that when the user writing apps, so when they try to connect to the database, don't provide the port number or the socket, and just give the database ID. Then that's it. Otherwise, if you fix to tell the app to connect to which DB, okay, probably on the system is not running. That DB is not running.
So if the user doesn't provide the port, which ports are you picking up?
Then the system will look up the port, right? Based on this configuration file.
No. So it's mandatory to provide the port in the multiple Redis instances config file.
I'm sorry, I didn't get.
It is mandatory. It's required to always provide then the port for each of the instances.
Yeah.
Okay.
Yeah, Don's proposal is that his module is playing the middleman. So application just say that I want to connect to this DB, and there's a lookup to find the port number and connect to the right instance. So the user doesn't have to know the port number. The application doesn't have to know the port number.
And that information that has to be readily available for people to easily be able to figure out how they're going to transition to the new model. I know we have applications actually that for our own reasons, they hook up directly to Redis. I know there are customers that actually do that as well. So
Okay.
I can assure you. So
So in that case, I recommend you open source that application to push it to a SONiC community. Then
no, it's certain. No. So currently we're interested in obtaining some information directly from the DB, or for example, where we want to track specific things like certain routes, right? So we register and we just listen, and when the change happens, we get notified, or we may collect only specific counters from the counters DB, for example. So we hook directly to the DB for grabbing some data that we use for telemetry and so on. It doesn't necessarily come always from the counters DB. So I mean, we can certainly open source, but I'm not sure how useful people will find that, because it's being used by other, the data is being consumed by other code that actually has the intelligence to figure certain expectations in the data center, like what routes need to be advertised, and if they're not there, rather than doing scraping from BGP and things like that, do something more intelligent. That's all.
I think the new API is pretty simple, even simpler than before. And
yeah, I agree. I just that I'm saying that if people have multiple applications, or they have shell scripts, or they have Python and whatnot, just make sure that it's easy to find how they can migrate their applications in this new model. That's all.
mm-hmm.
Do we have any numbers? Do we have any numbers regarding any performance improvements that we got out of this, or something?
So for the testing, so internally we are using some. I'm using about 40,000 routes to download it, to write into a database and see what the changes between before the changes and after the changes. So in our lab, probably the setup is not that strong. Then for example, I can provide some roughly number. So for example, if we try to write 40,000 routes into the database, if it's only one database instance, we say it takes about 7 seconds.
Okay.
And then if we change it to 2 database instances, and then we write the same because when we write the routes into the database, first it's write into the FDB, right? And
Yes.
then we read from FDB, then write it into the ASIC DB.
Yes.
Then now we have 2 database instances. One is running ASIC DB is running on one, and the FDB is running on another one. And then in this way, if we write the same amount of routes, saying 40,000, and then it takes about 5 to 6 seconds.
Okay.
And before it's about 8 seconds. So something, yeah. Okay.
So we get something like 20% performance improvement, right?
30%. yeah, something like this improvement.
Okay.
So what are the thoughts that when you split this DB into 5 instances, apparently you want to separate AppDB and ASIC DB? What are the considerations you put into this configuration file?
So for this it's just simple. So for our we use it. We want to change it. We want to split the AppDB and the ASIC DB. Maybe for some other user, they want to split some other DBs. It totally depends on the user what they want to put.
But here this is a recommended default configuration, right? Like this, for example, if current DB usually it takes a lot of resources, so we want to separate it from those APDB and ASIC DB. And for config DB, we want it's kind of isolation. It's from other application DB.
But you still put the flex DB counter and the PFC watch.db into the same DB as state DB. So is there any consideration, or is it just
I think for current DB that is easy to understand. So it usually at the regular time it takes most of the resources, and that is should be taken out of standalone from other DB. APDB is naturally it's should take one instance. ASIC DB is another instance. Then we have config DB, state DB, and flex count DB, PFC DB remaining. So since adding more DB instance does not take take very minimum resources, so it's natural to just put them separately. This is more for isolation. In case there's some bad behaving guy, then they could be isolated from other key function DBs. This is my understanding of this distribution of DBs in different instances.
Yeah, the main idea is we want, so for some databases it's very busy, some is not, and for those busy ones, then we want to split them, and for those one for the others we can put them together. That doesn't matter.
okay? So you did some analysis. CounterDB is very busy, apparently, right?
Yeah, but for CounterDB is very busy, and it totally depends on the application running. For example, if you have a lot of routes to write into the database, then the AppDB and the ASICDB is also very busy.
Is there benefit to separate the state DB from AppDB, or is there any benefit of putting them together versus to separate them? Which one is better?
You mean for StateDB and AppDB?
Yeah.
This part, I think maybe it's the same. StateDB didn't we didn't write and read a lot into the StateDB, right? I didn't test this case. Actually, yeah.
I think it's AppDB is in the critical path, especially in the busy scenario. While StateDB usually it's okay.
Do you have a case? So sorry, maybe that's not the right question. So do you think that everyone reads StateDB at some point will have to access AppDB? So put them together will reduce caching, paging, whatever.
StateDB. I think for now, usually only configuration related tasks use StateDB, right? Of course, there are very few cases that those FDB might write data into a StateDB, but that is not a very frequent use case, or not a very heavy weight use case.
Okay. Yeah, I don't know. This is just question. This is not a challenge or whatever. And just trying to see if there's anything that we can put together to make them go better. Or
Right. So here we try to figure out the best possible default configuration. Yeah, people might have some new finding or new use scenarios which might make sense to combine or split them more.
So I have a question, Dong. While dumping these, we have seen an issue, performance issue, where we were dumping around 10,000 MAC entries, FDB entries. It is taking an order of 4 to 5 minutes. So we can see some improvement on that.
Okay, I have to ask, right? Because so in the traditional data center, that scenario doesn't exist. You'll never see 10,000 MAC entries, even in VPN cases. So is this just out of interest? How long? How to scale? Or how the code scales, or how SONiC scales if we throw numbers at it, or is there a realistic scenario behind this?
We were just testing the scaling scenarios, like
Okay.
populate max. Yeah.
Okay.
But dumping FDB from which DB? From which DB?
We were using a script show Mac. I think it will be dumping from the app table, right? It will be querying the app DB and dumping, right?
I think maybe dumping from ASIC DB. In that case,
show Mac is the Mac.
SONiC, I think today those dynamic FDB exists in ASIC DB. But with recent change that we put those FDB into state DB. But that's a very recent change. I don't think that command has modified its data source. So I guess that's some implementation issue with that show Mac command. It was not using the Redis API in the best way.
Okay.
So actually, the Redis, the benchmark is very. Here actually you can see here's the benchmark for the Redis read and write is very quick actually. Then most likely the app has some bottleneck probably.
Right. I remember LinkedIn fixed some Mac SMP Mac fetching performance issue. Because they have some SMP agent to read the FDB periodically, and it's causing a lot of performance issue. And then do some optimization there.
Is that in latest?
I couldn't remember the exact details. They changed.
But you remember seeing it being upstreamed?
Yes, in the SMP repository.
Right. Yeah. So the other thing is, like, I think when one considers grouping of the databases, given the single-threadedness nature of SWSS, one probably would want to consider only things that live outside it, right? Like the routing application, syncd, how show commands are accessing things, and so on. Right? Does that make sense? Do we want to make any recommendation along those lines? Because there really is no point, for example, from from SWSS perspective, for anything to be separate. It makes no difference to it whatsoever. But it makes a difference for when you try to program the hardware, or when SIGD is trying to fetch routes, that it is separate instance from the app DB where FPM is pushing routes.
I think that depends on where data is stored. If the data only exists in AppDB or ASIC DB, then they have no choice but just fetch data from the specific DB instance. But I think with putting counter DB into a separate instance and ASIC DB in one instance too, that will help with those CR or those application performance a lot.
Yes, for sure. Yes, as long as I don't know. As long as you don't stall, because it's syncd that's writing into the counters, right?
Yes.
Right. As long as somebody's not stalling the counters DB, thinking that, hey, I'm not affecting anything, and it's just sitting there, and then counters DB is trying to write to it. Sorry, syncd is trying to write to it.
But usually many applications or many CR you just read from counter DB.
Yeah, of course.
Yeah,
that of course. But if you try to read things like if you write a script and it just sits there trying to fetch things, or you try, in one big chunk, and you try to read, let's say, 10,000 counters or whatever, and you do that frequently, then you could be impacting the system, even if it is separate instances, right? Because then every time syncd is trying to write to counters DB, it's going to get stalled, and it's just going to stay there and wait, right?
Yeah, that is always the application implementation issue. We should take care. I mean, should be careful with that because.
So my topic is done, and if someone have any further questions.
I have a question to Nikos. So I already posted that in the chat as well. So in the currently in case of warm reboot, right, with large number of routes like ALPM case where we have large number of routes. So still, do we see this timing issue where the database Docker has to be up before this BGP Docker starts reconciling?
No. BGP is not going to wait for anybody. Once the Docker service, the database Docker service is started, then I think, as Ying pointed out, that we're going to go through the rest of the Docker services, and the Dockers are going to start. And BGP won't care one bit. As long as it has a route to the peers, it's going to open a session, it's going to start receiving routes. And yes, it's going to be fast. They won't be affected by this.
Today, the restoration time, so the DB become ready time is about 1 or 2 seconds, so it's really trivial. It's not introduce a huge delay. It's way before the BGP container is even ready.
Okay. So I have another question, completely different, a different topic, where we have this issue where the link local address addressing the neighborship is not formed on the link local addresses for the BGP neighbors, and we have a pull request already for that. So just like to know if there is any outlook when.
So is there you mean you have a fix posted in one of the repos, SONiC repos?
Yeah, already there is a pull request. Okay, let me.
Are you talking about that a pull request from Rodney?
So
I pasted that is the pull request.
Oh, this one. I think Rodney said that he will work on it this week. I think last week he told me he would work on it this week.
Okay.
I don't know whether he could finish it in time.
Okay, so yeah, because this is supposedly targeted for the March release, right? Okay. So, Guohan, do you know if, because I didn't follow this, or Jipan, do you guys know whether the vendors actually implemented what is needed for link local support?
I think if you are talking about the Broadcom, I think they made the fix.
Okay.
But I need to confirm with.
Okay. So we're done?
Yeah, my topic is done.
Thanks.
Okay, thank you. Yeah, thank you for a very great conversation. I want to raise one thing that we are going to have one community meeting next week instead of a week after because the week after will be Chinese New Year. So many people from Asia won't be available. So we are going to move the bi-weekly meeting to next week. The tentative agenda will be two. One is from the Everflow part, what we are enhanced there, and the second part is the transceiver parameter tuning. Yeah, I will send out agenda in advance. Yeah. If there is nothing else, thanks everyone for your time. Yeah. Thank you. Bye.
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 Thanks. Bye bye.